Hello students, let's begin another topic that is about hydrogen chloride HCl. So hydrogen chloride is a gas. We will see the preparation first. So first one is laboratory preparation or lab preparation. So it is the reaction with the sodium chloride and sulfuric acid. So when sodium chloride is treated with concentrated sulfuric acid, we will get NaHSO4, sodium bisulfate and HCl. So this reaction happens at 420 Kelvin. So this is the first step. In the second step, we can write NaHSO4 plus NaCl. So if NaCl is present in excess, we can write the second step like this. Na2SO4 will be formed and HCl is again formed. So this is happening at 823 Kelvin. So this 823 Kelvin. So these are the two steps involved in the laboratory preparation of hydrogen chloride gas. So first of all, sodium chloride is treated with concentrated sulfuric acid at 420 Kelvin. We will get sodium bisulfate and hydrogen chloride. In the second step, if NaCl is present in excess, NaHSO4 reacts with NaCl at 823 Kelvin, produces Na2SO4, sodium sulfate and hydrogen chloride gas. So this is the laboratory preparation. Now let's see the properties. First of all, let's see the physical properties of hydrogen chloride. So it's a colorless gas. And it's a pungent smelling gas. It has pungent smelling gas. And about its solubility, it is highly soluble in water. So it is soluble in water. So these are the three important physical properties of hydrogen chloride gas. Now let's see the solubility in water. So hydrogen chloride is highly soluble in water, and we know hydrogen chloride gas when dissolved in water to produce hydrochloric acid. So let's see the equation. This hydrogen chloride gas dissolved in water produces hydrochloric acid. So it's HCl aqueous. So this is actually hydrochloric acid. So hydrochloric acid is formed when hydrogen chloride gas dissolved in water. We know that hydrochloric acid is a strong acid, and we can write the ionization. The ionization of hydrochloric acid, that is HCl aqueous, produces H plus and Cl minus. We know that H plus will not exist alone. It exists as H3O plus, hydronium ion aqueous plus Cl minus aqueous. So this is the ionization of HCl aqueous. And also the Ka value, dissociation constant, is 10 raised to 7. So if Ka is more, or the dissociation constant is more, the strength of acid is more. So if Ka is more, strength of acid or the acidity will be more. So Ka and acidity or strength of acid, that is directly proportional. So Ka or dissociation constant is more in this case. So it is a strong acid. So this is about the ionization of HCl or hydrochloric acid. Now let's see another reaction, that is actually a chemical reaction with the ammonia. So with ammonia, hydrogen chloride gas react and forms ammonia. So with ammonia, NH3. So with ammonia, NH3 reacts to form NH4Cl. Actually, we can see white fumes. So white fumes of NH4Cl, ammonium chloride, is produced when ammonia and hydrogen chloride gas react together. So white fumes are formed in this case, that is due to the formation of ammonium chloride. So this is another reaction. Now let's see another property, that is with aqua regia. So aqua regia, you know, it is a mixture of 1 part of HCl and 3 part of HNO3. So 1:3. So it's a mixture of 1:3 mixture of hydrochloric acid and nitric acid. So it's a mixture of, actually it is 3:1. So 1 part of nitric acid and 3 parts of HCl. So that is the ratio. So anyway, it's a mixture of HCl and HNO3, that is aqua regia, and you know it dissolves noble metals like gold, platinum, etc. So this aqua regia is a mixture of HCl and HNO3, and that dissolves noble metals like gold, platinum, etc. Let's see the equations. First of all, let's see the reaction with the gold. So gold is Au and it's a mixture of HCl and HNO3. So we can write H plus ions are there, Cl minus ions are there, NO3 minus ions are there. So this will be the reactant side. And the product side will be AlCl4 minus plus NO plus H2. So this is the product side. With platinum also we can write similar equation. H plus is there, Cl minus is there, NO3 minus is there. So this is the reactant side. And here the product side is PtCl6 2 minus and NO plus H2. This is the same. So these are the two equations when aqua regia reacts with the gold and platinum. So anyway, aqua regia dissolves noble metals like gold and platinum. So this is the reaction. Now let's see another reaction, that is with the carbonates, bicarbonates and sulfides. So first of all, it reacts with the Na2CO3. Na2CO3, it is sodium carbonate. So this is very familiar to you. Sodium bicarbonate NaHCO3. Then sodium sulfite Na2SO3. Na2S2O3. So when this reacts with HCl, it produces the corresponding salt. NaCl is the salt formed in all the cases, NaCl. Then H2O will be there, H2O, and the corresponding gases are, in the two cases it will be CO2, and in the last case it will be SO2. So this is the reaction. So with carbonate, bicarbonate and the sulfides, HCl reacts to form the corresponding salt, water and the corresponding gas. So in these two cases, carbon dioxide. So from carbonate, carbon dioxide gas will be evolved. From sulfite, SO2 gas will be evolved. So this is the reaction. Then one more reaction, that is with iron. So with iron, Fe plus HCl gives FeCl2 plus H2. This is the reaction. Actually, FeCl2, that is ferrous chloride, is formed in this case. Ferrous chloride, not ferric chloride. So it will not produce ferric chloride FeCl3. So this is a question. This is an important question. So it will not produce, or this Fe and HCl, that doesn't form FeCl3. Why it doesn't form FeCl3? That is an important question. So here the H2 produced will be acting as a reducing agent, and this H2 or liberation of H2 will prevent the formation of FeCl3. That is the answer. So Fe prevent the formation of FeCl3. So in this case, iron and HCl reacts together to form ferrous chloride, not ferric chloride. So ferric chloride will not be formed in this case. So why ferric chloride is not formed in this case? That is the question. So in this case, we can answer it like this. So the liberation of H2 will not allow the formation of FeCl3. That is the answer. So liberation of H2 will prevent the formation of FeCl3. Now comes the uses. So it can be used as the manufacture of chlorine, ammonium chloride, etc. Then it can be used in medicine and as a laboratory reagent. So it can be used as a laboratory reagent. So these are the important uses of HCl. So this is about hydrogen chloride.